We are here today to discuss Stavatti Aerospace, but because this is the Air Dominance Summit, we'll be touching a lot on next generation air dominance solutions provided by Stavatti. Moving through, Stavatti, we are an aircraft manufacturer. That means we design and make new airplanes. But things have changed a lot over the last 30 years since Stavatti Aerospace was incorporated. We've moved into a variety of different programs. As you might see, we have some close air support aircraft there. Close air support is a true passion of Stavatti, as is flight training and air cargo transport. Moving on, we have an exhaustive leadership team. You will never find an aerospace defense company of our size with this many directors, advisors, and other people who have a wide variety of experience, knowledge, and database. We did kind of a unique thing a number of years ago. We inherited much of the fighter mafia team. Remember the fighter mafia that was responsible for the F-16 and the A-10? Like, it's about 180,000 square feet, one of the largest freestanding hangars in upstate New York, and it's really the first hangar to have in-floor heating, which is kind of cool. Actually kind of warm in the winter. So that's kind of our focus there. We own 20 acres, which means we have to have a through-the-fence agreement with the Niagara Falls International Airport. That's a unique situation because most hangars on airports today are not owned by the company or the person, the party that actually rents them, or even they own them. They're owned by the airport, or leased on a land lease basis. But this is actually a facility that we own. We are certainly expanding for production. Now, the facility that we currently have is a headquarters in. Moving on, for this particular focus, we're really concentrating on three major aircraft these days. We have our SM-31, which is a single seat, take a long time. We started working on the undergraduate jet training program way back in 2017, if you can imagine. And of course, it's gone through a lot of different iterations and changes. We proposed three different solutions with our NATO allied partners, with our foreign allies in Asia, as well as commercial airlines worldwide. Focusing on the SM-39 Raider, this is our core next generation air dominance solution. This is an airplane that could serve as an FAXX or something else, or mostly as an F-15 replacement. That's really how we're marketing it internationally. It's a different kind of airplane. It's a unique design, and it's optimized to take advantage of next generation aircraft engines and next generation weapon systems and new approaches. What is remarkable about this particular design is a commercial solution to this particular realm. And our view is that once upon a time, there was another F-47 out there. We called it the P-47, and it was the Thunderbolt. And back in those days, America didn't just buy one particular type of fighter. We bought many types of fighters. This is an important thing to remember if you know your World War II history. We really had family aircraft. Today we have maybe 3 or 4, if you include Stavatti. That said, our view is not to go with a winner-take-all solution. What we need, perhaps in the entire world, is a situation that focuses upon multiple aircraft manufacturers making multiple aircraft. Moving forward, here's a pretty picture of the SM-39. As you see, it has large Vortex brakes right in the front for high maneuverability and to, more importantly, deal with the shockwave issue. If you're building a Mach 4 fighter and you need to carry internal weapons, this is a solution to allow this to happen. We'll show you a CFD slide further on that kind of indicates the value of having this particular configuration, which is unique. Now, unfortunately, while I came up with this design about 15, 16 years ago, I wasn't the first. It turns out, going back to an old McDonnell Douglas corporate report, on the cover of that corporate report, they had a tri-body, trimaran, high-performance fighter aircraft. And back in that report, which I believe was released sometime in the 1970s, they say, in the future, your fighter airplanes will look like this if you want them to go fast. So that kind of was a good mental tickle to say, wow, this is what the great minds of the 70s were thinking when it came to high-performance next-generation airplanes. Moving along, how do you power an airplane like this? Well, we started out working on this project in about 2010. By 2012, we were responding to FAXX requests for information, and we participated in a lot of their industry days up through 2014. And one of the big challenges has been what kind of engine is going to power this type of airplane. Of course, there's been all this discussion of variable cycle for many, many years. One of the core focuses we've had is taking next generation materials, mostly titanium cernas, ceramic metals, and integrating them into power plants, especially the turbine and compressor sectors. That led to this engine design we have here. While Pratt & Whitney and General Electric may provide a power plant for this aircraft, for the purposes of engineering over the last 10 years, we went ahead and focused on our own engine design. It took us about 3 years to come up with the design of this engine, which is a variable cycle, high-performance, 50,000-pound class turbofan. Variable cycle, it cycles between turbofan and, of course, turbojet. It has an afterburner, but the interesting thing is when you get into this level of performance, the afterburner doesn't do nearly as much as it used to in other aircraft. One of the hallmarks of Stavatti, we're pioneering new material approaches to build airplanes differently. It's very similar to your traditional, say, rattan-style composites, only we're not using styrofoam and fiberglass or graphite or Kevlar, we're using metal and metal. Here's a fuel tank distribution of the aircraft for those who are interested in fuel tanks. Moving forward, we're using a combination of electronic warfare systems. Right now, you're seeing the standard Barracuda configuration that the prototype will use, but we're looking at some very comprehensive AI solutions that we believe will be derived from the F-47 and what Lockheed has developed, as well as new systems we may find in the F/A-XX, especially exportable systems. Here's that CFD picture I was alluding to. If you look at the CFD distribution, this particular airplane is modeled at high speeds, about Mach 4. The airflow never exceeds Mach 3. This is a wonderful configuration in that sense because the whole purpose of high-speed flight, sweeping your wings, is really tricking the air into believing that it's going slower than it really is. So while you may be traveling through the air at Mach 4, the airplane itself might only be traveling about Mach 2 or Mach 3, allowing us to achieve those kinds of efficiencies that you need. This is a good way of reducing your overall sonic boom and footprint, which means it's a quieter airplane. And this particular design configuration has led to its own quiet supersonic transport configurations within our company. And we're very proud of the future potential of supersonic business jets and airliners using this knowledge base. Here are some images of various aircraft structures. When you look at our designs, these are not concepts. Concepts are things we draw on the back of a napkin, quite literally, many of those to show. We have probably over 10,000 concepts over the history of our company. I like to draw airplanes. But what these really are is fully engineered designs, not just from the CFD and the FAA, but the structural configurations. In the case of the Machete series that you see, I guess that would be to the left, you can see we have a unique structural configuration inside, which combines bulkheads with the foam metal sandwich structure. In the case of the Razor image, we're not exactly portraying everything that is out there. One of the interesting things about the Razor and everything I presented you here today is that this was our 2014 design. It's not the design that we're releasing into prototyping and production, but will be the design that we're sharing to the public for marketing purposes and to disseminate that we're working on this particular program. One of the advantages of the foam metal structure approach is that we don't need to have that many internal bulkheads, which opens up the airplane to dramatic expansion potential, gives us a lot more internal volume, and allows us to have an open architecture system where it's plug and play over the years to come. This particular airframe is designed for long life. When we started this project, our focus was range, the ability to take off from Diego Garcia and hit a target. It's very critical that range is the main driver of this design. How do you get a high-speed airplane with long range? Now, when we say it's a Mach 4 airplane, the question is how long will you fly from Mach 4? Not very often at all. Most of the time, this airplane will be flying at about 0.9 Mach for long-range cruise. The Mach 4 part is the dash speed. In that sense, cruising at your standard cruise settings, you're looking at an airplane with internal fuel only of about 3,000 nautical miles. This is a major game changer. With internal fuel, combined with external fuel, one of which is an internal weapons bay extended tank, your range goes up dramatically. So the goal of this particular airplane is to have an extreme long-range, high-performance fighter that can really make a difference when it comes to air dominance. You know, generally speaking, you don't want to come in second place in a gunfight. And that's the mission of this airplane, to ensure that never happens. Here we have some contact information. I'll leave you with today is the fact that Stavatti is expanding. We're easy to reach. We're here to do business. We love the industry. We love airplanes. And we want to thank everyone for your attendance and participation.